Here we're asked to add the fractions as indicated, writing our final answer in simplest form and using our calculator to check our work. Take a look at the first one, 1/2 plus 2/3. We cannot add these the way they are because the denominators are different. So what I need is a denominator that both 2 and 3 will divide into evenly. When in doubt, I can always work with 2 times 3, in this case is 6. So the way I convert, I want 1/2, I want to write that as a fraction over 6 that's equivalent. Well, 1/2 is equivalent to 3/6. I can see that because 3 is half of 6. The way I build that up from scratch is I say to myself 2 divides into 6 3 times. 3 times 1 is 3. So let's do that with 2/3. 3 goes into or divides into 6 2 times. 2 times 2 is 4. So I can always reduce back and be sure that 4 and 6 have a common factor of 2. 2 times 2, 2 times 3 would reduce to 2/3. But I don't want to reduce at this point. I have to have these fractions in a form that has the same denominator for each one so that I can combine the numerators. So I have 3/6 plus 4/6, which gives me 7/6. So let's see what that looks like on our calculator. So if I start with 1/2 plus 2/3, I want to end up with a fraction. So I'm going to go to Math, Fraction. It's going to give me the final result. But what's going on here behind the scenes in working with these denominators is important for you to understand. So be sure that you're working these out by hand first and then checking your result on the calculator. Let's go to part B. 3/8 plus 5/6. I want a number that both 8 and 6 will divide into evenly. Worst case, I could always use 8 times 6. However, there's a smaller number that both 8 and 6 will divide into evenly, and that is 24. So 24 is 3 times 8. 24 is 4 times 6. So 8 goes into 24 3 times. 3 times 3 is 9. 6 goes into 24 4 times. 4 times 5 is 20. I have 9 over 24 plus 20 over 24. That means I can now combine the numerators over the common denominator. 9 plus 20 gives me 29. 29 over 24 cannot be reduced, and it's fine to leave it as an improper fraction. Let's double check on our calculator. 3 divided by 8 plus 5 divided by 6. I want the answer as a fraction. Enter. Gives me my result, confirms 29 over 24. For part C, I have -2/5 plus 7/4. I need a common denominator between 5 and 4. 5 times 4 is 20, so I'm going to use that. That's the smallest number that both 5 and 4 will divide into evenly. 5 goes into 24 times. 4 times 2 is 8, but don't forget that negative there. 4 goes into 25 times. 5 times 7 is 35. Now I can combine -8 plus 35 over 20. That gives me -27 over 20. Again, let's check on our calculator. -2/5 plus 7/4. Final result as a fraction. Enter. Confirms. We made a mistake. Do you see the mistake? 27 over 20 was the result. We got -27 over 20, so let's see what happened there. We had -8 plus 35 and indicated that would be -27. That should actually be a +27, so let me get rid of that. So that's why it's good to be doing the problems by hand, but then also double checking them on the calculator so you can confirm your results. Let's look at part D. 2 1/3 plus 2/5. In order to convert 2 1/3 to a denominator that's going to be compatible with 2/5, I first need to write this as an improper fraction. 2 times 3 is 6, plus 1 is 7/3, plus 2/5. I'm going to use a common denominator of 15. 3 times 5 is 15. 3 goes into 15 5 times. 5 times 7 is 35. 5 goes into 15 3 times. 3 times 2 is 6. I should end up with 41/15. There are no common factors between 41 and 15. This should be my final result. Let's double check on our calculator. 2 plus 1 divided by 3 plus 2 divided by 5. I want my final result as a fraction, so I press Math, Enter, Enter, confirming the final result of 41 divided by 15.